Okay, hello everyone and welcome back to the Day 4 workshop for the E3 2023 Meta Web3 Builder Competition. My name is Kyle and I will be your host today. E3 2023 is a Web3 summit dedicated to Ethereum and designed to gather developers and builders from Riyadh, Saudi Arabia, and other Middle East regions. E3 aims to provide insights from industry experts and engage in discussions around the future of blockchain. I want to thank the Community Organizing Committee, Therawatt Technology, Studio 1727, Chain IDE, Coffee with Crypto, and Mask Network. The event schedule for E3 includes this online boot camp and competition from September 18th to October 10th, the in-person reception and conference on October 10th and 11th, and the online closing mixer on October 12th. And thank you all again for joining us for day 4. Just a quick reminder that registration for the competition is open right now, and there is a prize pool totaling $30,000. We'll be hosting daily workshops through the 28th, and the competition submission deadline is on October 10th. If you want any more information about E3 or this competition, please visit e3od.com, follow 0xE3od on Twitter or X, and join the official E3 Telegram. Before we get started, let's thank our event sponsors, Web3 Port and Moon Capital. And now we can jump into day 4. So for today's schedule, we have 2 workshops. One will be with Joe, Product Manager of RelationLabs, and the other will be with Fabio Costa, a core dev at Push Protocol. If you have any questions during today's session, please leave them in the chat. The team will gather them, and the answers will be posted at a later time in the official Telegram. Now let's go to Joe, Product Manager of RelationLabs, for his workshop, Encode Social Relationships in Web3.
Hi everyone, I'm Joy from RelationLabs. The theme I shared is about encode social relationship in Web3. Social represent a fresh frontier in Web3. As we observed, data of Web3 users are dispersed across various networks and protocols. Each having its unique data structure and accessibility procedures. This presents a challenge landscape for new developers aiming to access and amalgamate data from diverse sources, essentially placing significant constraints on the expression and interoperability of non-financial applications. Succinctly, while today's DeFi ecosystem exhibits commendable composability and consensus, other sectors seem to function in isolation. In a nutshell, the problem is excessive fragmentation of data in the Web3 world, an issue that Relation aims to address. Our solution is to create a data abstraction layer. By providing a unified model and a data access standard, we aim to standardize data and abstract the complexities of various applications. This makes the data abstraction layer more scalable. Simultaneously, adhere to these standards can simplify the Web3 development process, allowing everyone to seamlessly integrate into the Web3 world. At Relation, we generally refer to this data abstraction layer as the semantic layer. We construct the semantic layer by integrating design pattern from the semantic web with on-chain data storage method. Combining semantic networks with SPT, we envisaged an architecture for Web3 social protocols. On the right is the common data storage structure of a social graph in the Web2 era. Almost all social products during the Web2 era introduce graph database to handle search and recommendations on the data reaches a certain level. This is something we can't currently accomplish on the blockchain. Hence, we plan to disassemble the graph database and store sections of data on-chain to co-create a social graph in the Web3 world. We say co-create because Web3 social protocols should allow any developer to deploy contracts, set up on-chain business, and define special data structures. It should include at least 4 components: schema standards, contract open standard, public API standards, and graph indexer. Schema standards are the guidelines. All social data formats building based on relation protocol must adhere to RDF schema and base schema. RDF is a standard for semantically describing knowledge structures, and is also an international standard for knowledge graph set by W3C. Base schema consists of several TTL files stored on distributed storage, like Arweave. It's upgraded and maintained based on community consensus. It serves as a reference standard for creating social graph, akin to setting up a schema for building a local database. Contract open standard should be some smart contract standards built based on the schema standard. These are the initial contracts for constructing a social graph. Of course, they can also be viewed as a contract template, encompassing basic behaviors and elements in the social network, such as identity, relationships, and content publishing, among others. The identity system should be a type of DID, mainly applied in social networks, similar to your Twitter or Telegram handles. Relationships include follow and DAO relationships, which are point-to-point and group relationships, respectively. Content publishing currently includes 2 modes: public content and private. Of course, in addition to the most basic contracts, the protocol should support developers in extending basic contracts, as long as they meet the schema definitions. The third part is the public API, which is also the core of the protocol's application. As previously mentioned, we aim to combine semantic networks with blockchain data storage. In implementation, by merging NFTs and RDF triples, we call this semantic SBT. Relation has submitted a semantic SBT proposal to the community, which is also EIP 6239. As the EIP are usually interface specifications, we consider it compliant with our interface definition if we can query RDF through the interface method. Here, there is an interface definition called asemantic SBT, which includes 4 methods: create, update, delete, and retrieve. The most relevant to social applications is the graph indexer. Any developer able to listen to blockchain transactions can index all semantic SBTs and recognize the data according to RDF, thus generating a Web3 social graph. We support constructing indexer with the mainstream graph database, including Neo4j, Gina, Neptune. Moreover, any third party should also be able to construct graph indexers to provide servers in social realm similar to the graph. Based on the social graph protocol, we have an API product named Relation Graph. Here is a video talk about the Relation Graph.
What is Relation Graph? Relation Graph is an advanced social data access layer designed to bridge the data silos between Web 2 and Web 3. Through it, developers can easily integrate and connect the rich social data of these two worlds, providing them with an accurate and efficient unified social data platform. What can developers achieve with Relation Graph? If you are a DeFi product developer looking to build more personalized financial services, you can leverage Relation Graph to assess user identity risk, cross-analyze multiple addresses to determine the likelihood of a Sybil attack, offer users higher borrowing limits based on risk assessment. Additionally, with user-authorized social relationships, help them track investment trends in their social circle and capture potential investment opportunities. If your GameFi business growth has hit a bottleneck, consider using Relation Graph to obtain user-authorized social relationships to provide users with personalized game tasks, enhancing the gaming experience. Mark high-risk users based on address account risk assessment, ensuring a safer and more reliable gaming environment. Analyze social data to help track the gaming sentiments of whale players and optimize game content. Seamlessly import social relationship friends to increase player game stickiness. If you are considering designing a highly innovative and interesting social fi, don't worry about the cold start problem. You can use Relation Graph to obtain authorized user tags to match users with appropriate social content. Obtain user-authorized social relationship graphs to easily help them seamlessly migrate to your platform. Assist users who hold common NFTs in quickly forming communities. Additionally, if you are building a dApp with abstract account capabilities, Relation Graph can support you with social account recovery capabilities. Recommend suitable guardians for social recovery based on user-authorized social relationship data. And through risk assessment, alert potential risky social accounts, helping to maintain the security of users' abstract accounts. Now, let everything connect through Relation Graph.
Here are two use cases that we particularly favor. Wallets can incorporate Web3 social features via social applications, including update to the contact list, chat functions, and even Instagram and more. The combination of gaming and social graphs is also quite fascinating. We can conveniently add a friend system and instant messaging to a simple Web3 blockchain game. Finally, we invite everyone to join us in co-creating the Web3 social ecosystem.
Okay, thank you again to Joe of RelationLabs. For our next and final workshop for today, we're going to Fabio Costa for how to power your Web3 dApps using push protocol.
Hey everyone, so today we're going to be talking about what push protocol is, what problem it solves, and most importantly, by the end of this workshop, we're going to be doing a lot of demos of how you can integrate notifications, chat, and video calls into your own protocol. So we're all used to receive notifications from Web2 services. We receive a notification whenever someone sends you a new email. We receive a notification whenever someone deposits money into our bank account, or receive a notification whenever our favorite influencer tweets about something. So the concept of notifications is not new at all, and we're used to Web2 services to reach out to us to inform us about something that we're interested in. The thing is, in Web3, there was no such a thing before push. There was no way for protocols to reach out to users to inform about something. And the question is, why would protocols would like to reach out to users to inform a particular user? And here are some applications for this. Imagine your favorite DAO, they have created there's a new governance proposal, and let's say it's a very important proposal and you are part of the DAO, so you want to be an active member and cast your vote for a governance proposal. Well, for the user experience point of view, it's much better if you receive a notification whenever there is a new governance proposal, instead of you going, for example, to Discord or Twitter and be always up to date to all the governance discussions, right? It's much better for you to receive a notification whenever there's a new governance proposal. Another application for this is for DeFi. It's much better user experience to receive a notification before you actually are liquidated, right? It's not good user experience for the user to go to the DeFi protocol and keeps checking their collateral to see if they're not getting liquidated. Lastly, for NFTs, so whenever, let's say there is you have a very nice NFT and you put your NFT into auction, it would be very nice for you to receive a notification whenever someone places a bid on your NFT. So the applications are completely endless, but the point is just there are a lot of use cases where notifications are very, very important in Web3 space, and the concept of notification is not new at all. So the solution that Push Protocol is building is, first of all, it is a open communication layer. That means that any SDK, any client can simply tap into the network and fetch, for example, all the notifications from a particular wallet address, or they simply can fetch all the chat messages from a particular wallet. The notifications that Push Protocol is building, they are completely dynamic. That means that what the notification is going to look like, what's the notification payload is going to look like, it is completely up to the protocol to decide what's going to look like. For example, it can be a governance proposal, it can be a YouTube video, it can be a chat message. You can receive a notification saying that your friend 0xabc has texted you. And lastly, the solution is multi-chain. So Push Protocol, we are deployed on a lot of EVM chains, and soon we're going to be deployed on non-EVM chains as well. It is gasless, so for me as an end user to receive the notifications, I don't pay at all. And also for protocols to send notifications to the end user, as long as the notifications are off-chain, the users don't pay at all, because Push Protocol will provide both on-chain and off-chain notifications as well. On the demo, we're gonna explain the difference, and we're gonna do a code demo explaining the difference between those two. But if you just want to notify using sending off-chain notifications, then it's completely free. Lastly, it is platform agnostic delivery. That means that you're gonna receive the notification we have multiple front ends. We have our mobile app, we have a browser extension, we have our own dApp, but by no means you have to install any of push protocol front ends to receive the notification. Any protocol that uses push SDK or simply call push nodes directly, they can display the notifications to the end user. So the solution is front-end agnostic. Users don't need to know that push protocol exists to display the notifications. So for now, push has sent over 45 million notifications. We have over 9,000 different subscribers, and we have over 600 integrations. And the point is to showcase, since notifications, they are completely dynamic, how a particular protocol is going to be used. It's going to be using notifications to reach out to you. The user is completely up to the protocol itself. So we can see we have a lot of applications for DeFi, DAOs, NFT infrastructure and services, as well as social. So the applications for notifications, they're completely endless, and it's up to the protocol to decide how they're going to integrate this. So as I said before, push protocol, we have started with notifications, but this is just how we started. Push protocol also has we have something called push chat. We have built a wallet messaging protocol, where wallets can message each other, wallets can create a group chat, wallets can video call each other. So we're bringing all the Web2 user experience that we have, and now we're bringing this into Web3, where your identity is your wallet address. So no more need for phone number, email, or Discord IDs. You can handle all your communication using your wallet address. So as we can see here, we have here on the left how our dApp looks like, and here on the right, our mobile app. And as I said before, users don't need to go to push protocol, dApp, or mobile app to see the messages or see the notifications. Both our mobile app and dApp are using our own SDKs. So all this interface here can be used in any dApp that integrates push protocol, but we're just displaying here to showcase how the chat looks like. So what we can do with push chat, well, we can create native Web3 communities where we send messages using our wallet addresses. We can create group chats. We can create public group chats, token gated group chats, private group chats. We can create a NFT gated group chat where you only join the particular group chat if you hold a particular NFT. So we can see amazing applications that can come out of this. And of course, we have SDK where developers can easily integrate notifications chat or video chat into their own protocol. And in the demo, we're gonna dive deep into the SDK part. We recently announced something called push spaces. So the concept, it is exactly like Twitter Spaces, where the idea is with my wallet address, I can host a space where people can simply join audio only this space and ask questions and add reactions, and where people can start talk and interact with each other on different ways. So we can increase user engagement, user experience using only our wallet address. This is how push spaces look like, as we can see here. It's very intuitive. The concept is very similar to Twitter Spaces. The difference is we're using wallet addresses to do this. Here I have two videos. Here on the left, it just showcases how our mobile application looks like. And here on the right, showcasing a very early version of wallet video call. We have completely changed this, but this is a video showing how the wallet video call looks like. And here on the left, what we're doing, we're just synchronizing all the messages from our dApp with our mobile application, so we can we're going to download all the messages to our mobile app, so we can have the same experience from the mobile application in our dApp. And here on the right, we see one of our interns video calling himself using only his wallet address. Cool, so now let's start with some code demos. So now let's take a look on the push protocol dApp. Here on the left, we have 4 menus. We have the inbox menu, channels, chat, and spaces. So first of all, let's dive deep into channels. So channels, they are simply protocols that you as an end user can opt in to start receiving notifications. So for example, we have a push protocol channel, we have Shapeshift governance channel, we have CoinDesk, Snapshot, Lens, and so on and so forth. So the idea is you as an end user, if you want to start receiving notifications from any of the protocols listed here, what you have to do is come here to the channel section, find your favorite protocol, and then opt in. So for example, let's go into this Aave protocol. Let's say that I want to start receiving notifications from Aave. All I have to do is come here, click opt in. See, all I'm doing here is signing a transaction. There is no gas involved here, right? So I want to start receiving notifications from Aave. I click on sign, and boom. Now, whenever there is a new notification from Aave, I'll start getting notifications from them. And let's say from any given reason, let's say that I want to stop receiving notifications from this particular protocol, all I have to do is come here to opt out. I sign a message again, and then I will no longer receive notifications from that particular channel. Once you have subscribed or opt in to a particular channel, you're going to start receiving notifications. And so the question is, where do the notifications land, right? So as I said before, the notifications, they are platform agnostic. So that means that any front end, any protocol that integrates push protocol, they can display the notifications. That means our own dApp, right? Our own dApps bit is built using our own SDK. So let's take a look. Here on the inbox section, those are all the notifications that I have received. In this example, we can see here that I have notifications from Shapeshift and CoinDesk. See, and cryptocurrency jobs and so on and so forth. But any front end that integrates push protocol SDK, they can display the same notifications here in your own dApp. So this is how the notification looks like. So we also have another section here called chat. Once you click here, this is how the chat looks like. And yeah, from here I have logged in with my wallet. So then I can start messaging my friends, creating group chats. I can video call them. See, then I can simply go there and start messaging people from here. Now what we're going to do is we're going to create a channel and actually start sending notification to people. We have just seen how to receive notifications. It's simply a one-step process. I have to simply opt in into my favorite channel, and then I'll start receiving the notifications, and then the notifications, they can be displayed anywhere, right? In this example, we just seen how we can see the notifications from our own dApp, but on the other demo, we're gonna see how we can use the push SDK to display the notifications in your own dApp. Now let's see how you can start sending notifications to your users. For this demo, we're going to be on the staging environment, and the URL for this is staging.push.org. We can see, since I have a channel already created, here on this section, we're gonna see my channel name, that in this case is demo channel. So since I have created a channel already, the only difference, if you haven't created a channel already, here we're gonna see here a button called create channel. And all you have to do is just stake 50 push, and that's all. It's a one-time payment, then you can start notifying your users. Now I have this channel created already. Let's start sending notifications to my users. So my channel name is demo channel, so it's correctly selected here. So we have 3 types of notifications. The first notification type that we have is broadcast. That means notify every user that has opted in to my channel. We have targeted notification. That means, hey, notify only this particular wallet address. Lastly, we have subset notification. That means notify an array of wallet addresses. For this demo, let's just notify everyone. So in this case, we want a broadcast notification. Let's add a title for to our notification. So I'm gonna enable the subject here, and the title is gonna be my notification title. And here at the bottom, we're gonna see a notification preview. And let's add a notification message. It's gonna be hello world. We can add an image to our notification. We can also add a CTA link. That simply means call to action link, that whenever someone clicks on your notification, they're going to get redirected to this particular URL. In this example, let's just go to youtube.com. I'm satisfied with how my notification looks like, so let's send the notification. As we can see here, all we're doing is signing the notification payload, so there's no gas involved into sending the notification. We only paid upon channel creation, that was 50 push, but to send the notification, it's completely gasless. So all I have to do here is sign. We're preparing the notification is getting dispatched to our push nodes, and we see here we have just received the notification here. Why have I received the notification? It is because whenever we send a broadcast notification, that means that we're sending notification to everybody, including myself. So we just saw that we have received the notification here. If we go to the inbox here, we can see the notifications here as well. So if I click, I go to YouTube. How the notification payload looks like, it is completely up to you. So you can add, as I said, call to action link. You can add images, videos. You can customize your text as well. So you can add bold and italic, URLs, and so on and so forth. So this page that we're looking at right now, it is under our docs.push.org page. So we have been currently working on a lot on our documentation to make it as simple as possible for the end user. So this section here, notification content, is under docs.push.org/developers. You go here under sending notifications. So in this section here, we see different ways of how we can send a notification. We can send notification using smart contract, using our dApp, which is the one that we just did, using the SDK, which we're going to be doing on the next video, using our framework application, we call it showrunners, using subgraphs. But in this case, we just want to see the notification standards. We click here under advanced and notification payload. Now let's see how we can use the SDK to send notifications. So instead of sending a manual notification, we're going to automate this process by using the push SDK. Now let's send a notification using the push SDK. As we saw in the last video, we send a notification manually. Now let's automate this process by using the push SDK. So all the information that you need for this is just go to docs.push.org/developers, and we go under the sending notification section. Then we are interested in sending notification using the SDK. So we just click on this option here. So for this, all we have to do is to install the REST API package as well as the ethers package. The steps are pretty straightforward. We just import the SDK, and here is simply the code that we need to do to use to send the notification. So I have copy and paste this code into Visual Code. So let's take a look here. Let's go over this code. So what we're doing here is just import all the dependencies necessary. We're importing here my channel private key. So what is a channel private key? It is here. So if we go to staging.push.org, on this wallet here, I have a channel created. So that's my channel. So whenever we say channel private key, we mean the private key from this wallet here, right? So that's whenever we say channel address, we mean this wallet address here, the same wallet address that has created a channel. And whenever we say channel private key, we mean the wallet's private key that has created a channel. So I just exported this wallet private key here. and then added. That's the one here. I added into my .env file. Then I just instantiate a wallet class here. In this example here, we're going to be sending a notification to this particular wallet. So we're going to be sending a targeted notification. So we're just notifying this wallet here instead of a broadcast notification that we have sent on the previous video. Here we have the channel address, which is simply the wallet address that you have used to create the channel. And then we just have the notification title and notification body. So let's add a notification title here. We're going to be adding my title here, and my notification body will be my notification body. Right, so this is the code to send a notification, and this code I just copy and paste from the documentation. This is just a targeted notification which has a call to action link. Whenever a user clicks on this notification, they're going to get redirected to, in this case, YouTube. And we're sending notification in our staging environment. So that's it. So let's run this code. For this, to run this code, we're just going to run ts node index.ts. As we can see, we're calling the SDK, and it ran successfully. So let's go to that address. We saw a pop-up here. So if I go to the inbox here, so I have logged into another browser. So that's the address that we have sent the notification to, and as we can see here, the notification is here, right? So if I click here, then I'm redirected to YouTube. And since as we say, the notification, it is the push protocol is platform agnostic, so that means that we have received the notification here in the dApp. We have also received the notification here in the browser extension. We have also sent a notification to any mobile application that has integrated push SDK. So that means any front end that has integrated push protocol has received this exact same notification. Now let's see how we can use the push SDK to send chat messages. As we saw previously, we can use the SDK to send notifications. We can also use the SDK to display the notifications. And in this example, we're going to see how we can integrate push chat in your protocol using the SDK. In this example, we're simply going to be see how to send a chat message. So all the code we're going to be doing in this demo is taken from our own documentation. So you just go to docs.push.org/developers. And if you go in the left menu under push SDK and you go SDK packages, push protocol REST API, and we're interested in for chat section. And here we have some code samples from the chat, how to initialize a user, how to fetch all your chat messages, how to send messages, everything related to group chat, and also the helper functions from the SDK. In this example, we're interested in sending a chat message. So the code is pretty straightforward. So I'll just copy and paste this code from here into Visual Code. So let's go there. Okay, so just copy and paste the code here. So let's take a look. So we're just importing all the necessary dependencies. So it's just the REST API SDK, ethers, and in this case, we're using the .env package as well, because we're going to be adding my private key here. So I add here my wallet private key. So that's the private key from the wallet I want to send a message from. So I'll be sending a message from this wallet. And the message is going to be sent from the staging environment. And it's important to get the private key here, and then I get the signer using the ethers library. So let's send a message. So to send a message, there is just a three-step process. First, I need to get my user object. The user object is the object that contains all your user information from the push network. That it contains also your encrypted PGP private key. And that's exactly what we need. So first we just fetch your user information from the network. Then from this user, we get the encrypted private key. And then we use this method here from the SDK called decrypt PGP key to decrypt your PGP key. With your decrypted PGP key, you pass this to the send function from the SDK to send actually your chat message. What we're doing here, we're sending a text message with a content hello world to this particular address here. And then we just pass the signer and the environment and your PGP private key. So let's send this message. I'll go under this folder. So let me just run this code. The code is running. Let me just maximize this. Now the message has sent. So this particular user here has received the message. So let's log in to this user. So it is under here. See, I have received a notification here already. New message from this wallet. So as we can see, we received a notification from that particular message, because whenever we receive the chat message, we also receive a notification because everything's integrated. So I'm just logging in this wallet. I'm decrypting my profile. Then in the background, I'll be decrypting all my messages. And as we can see here, we have received a message, hello world, from this address here, which is the same address from here. That's the address we have to send. That's the address we send the message from. As we can see here, we get the message here. So all the information from how to use the SDK for sending messages, receiving messages, creating group chats, it can be found in documentation. So we have here this example we just did is how to send messages, but of course you can use the SDK to fetch all your chat messages. All right, these are the response types, and we have created a code here where we go through every single SDK function related to chat, so you can see how to use it and a detailed example how to use this. So all this code here is under our own GitHub repo. So it's under push SDK repo. We go to packages, examples, SDK backend, node, source, chat, and chat.ts. So here are all the functions related to the chat SDK. How to create a user, how to get a user, how to decrypt the PGP key that we just saw, how to fetch all your chat messages, how to get all your chat requests, how to send a message, how to approve a request, how to create a group, chat history, latest message, updated group, so on and so forth. So I highly recommend you go to this repo here, examples folder, to see a detailed code on how to use the push SDK.
All right. Thank you so much, Fabio, for that wonderful workshop about using push protocol. So that was our final workshop for today, day 4. Thank you everyone for joining us. I hope you enjoyed these workshops and I hope you are learning something from them. We will be back at the same time tomorrow for day 5. And remember, if you want all the latest information and updates about E3Riyadh and the competition, make sure to visit e3riyadh.com, join the official Telegram, and follow 0x E3Riyadh on Twitter. Thank you all. Bye.